students, welcome to our physics class. Our chapter name is motion and time. In the last class we discussed about different types of motion. Today we are going to discuss the further topics. First topic is measurement of time. Measurement of time. How we are measuring the time? We measure the time using clock. Now we are using clock. Now my question is, how the ancient people measured the time? Do they have clock? No. They do not have clock or watch. Then how they measured the time? That is a question. Have you ever thought about that? Now we are going to discuss how that people measured the time. Now just observe here. This is our earth, sun, one person, and he just come here at the morning, at the noon and at the evening, and just observe his shadow. He observes his shadow. My question is this: do all the shadows having same size? No. In each case, the size of his shadow is different. What is the reason for that? The reason is this: the sun is getting displace its position. Why it's just displacing? This person feels like that, but actually who is moving? Our earth is moving. And because of that, the position of the sun is changing. When this person is looking, sun is changing, or the position of sun is changing. And that's how the size of the shadow is varying. Now, you don't want to get confused about that. Just focus on the size of the shadow. And the ancient people measured the time using or considering this shadow. And they just identify the time by looking the shadow. At some time the shadow is small, at some time the shadow is big, and they get identified the time. So, by considering the shadow, they used a device called sundial. Sundial. This is a device used to measure time in the ancient period. And also another type of devices are there, that is water clock. Water clock and also sand clock. These are the some of the type of devices ancient people used to measure the time. You can see the diagram of these in page number 149, and you just observe that. So just remember the names of these: sundial, water clock and sand clock. So this is all about the devices we used in the ancient times to measure the time. What is one day? Now we say it as 24 hours or this much minute, like that. My question is not like that. What is the one day for ancient people? How they defined this? I just said that this time, this second or the minute is something defined or invented after some time. So my question is, before the invention of this second, minute, like that, how the day is getting defined? That is my question. So one day can be defined as the duration between, this is the duration between one sunrise to one sunrise to next sunrise. So, we can define this one day very simple like that. What is this? It is the duration between one sunrise to next sunrise. We know it is 24 hours, and this, and in the similar way they are defining this one day. It is the duration between one sunrise to next sunrise. Now the question is this, then how we can define 1 month? We are talking about the period which there is no calendar. So now the question is, what is 1 month? They define 1 month as the duration or the period between one new moon to next new moon. So 1 month is the duration between or the period between one new moon to next new moon. Now the question is, what is new moon? According to the size of the moon, there are different names for the moon. I just tell you what is this new moon. When the moon is in full shape or in full disk, we call this as full moon. And by passing the days, it will change its shape. Likewise, continuously when we are observing day by day, at a particular day we can see that there is no moon. That is what? That is new moon. New moon means there is no moon. That is new moon. And full moon means the full disk of moon can be visible. So, 1 month can be defined as it is the duration between one new moon to next new moon. So, this is the definition for 1 month. This is how the people defined 1 month at the ancient time. Now, in the similar way, how we can define this 1 year? What is this? 1 year is very simple. It is the time taken to revolve the earth through the sun. That is, we know sun is at the center and our earth is rotating its own axis and revolving around the sun. This earth is revolving around the sun. So, 1 year is the duration or the time taken to complete one revolution of earth around the sun. That is what 1 year. That is time taken to complete one full revolution around sun by earth. So this is 1 year. That is, the ancient people consider nature to identify the time. They just use the sun and they are defining this one day using the sunrise and next sunrise, or they are just defining 1 month using the moon, or they are just considering the motion of earth like that. They are just considering the nature and they identified or measured the time. Now, in our today's, how we are measuring the time? We are using clock. Now, today we are using clock and all. What is the old type of clocks? Have you ever observed such clock? It is something different from today's clocks. That is pendulum clock. And what is this pendulum? I just show you something. Actually, the pendulum clock is working with the help of this pendulum. That is, this clock is showing the time by the motion of this pendulum. So, for this pendulum, it is having a structure like this and we call it as pendulum. And it is moving forward, backward, forward, backward. Likewise, it is continuously repeating its motion, and that's how we call this motion as periodic motion. We discussed in our previous class. Periodic motion. That is, it is moving forward, backward, forward, backward. Likewise, it is moving like this. So, this is a type of periodic motion. Periodic motion means it is a uniform motion. It is repeating continuously. It is repeating continuously. So, this is what the previous clocks working. And today we are using the clocks which is working using battery or cells. And such clock is actually working with the help of quartz. Quartz. And so, now you no need of thinking of this. Just remember, it is working with the help of quartz. And so, the working of such clocks are very complicated, but they are more accurate than this pendulum clock. That's why nowadays we are using this quartz clock. Now we want to discuss about the pendulum. We said that this pendulum is having a periodic motion, and that periodic motion means it is continuously repeating its motion. And now we want to study this pendulum in detail. Pendulum. When we are talking about pendulum, there are different types of pendulum. Now you just want to study very simple things about this pendulum. So, when we are talking about this pendulum, it is of simple pendulum. Compound pendulum. That is, there are different types of pendulums are there, and it includes simple pendulum, compound pendulum, and also having different types of pendulum. Now we want to study only simple pendulum. What is the simple pendulum? The structure of the simple pendulum is very simple. It is having one thread and it contains one ball-like structure at the tip of this thread. And we call this ball as bob. B-O-B. Bob. And this is a very nice thread, and we are hanging some bob at the tip of this, and we are just making the motion. That is, it will move to here and here. So, I am calling this motion a name, and that is to and fro motion. That is, here is a motion occurs, forward, backward, and I am calling that to and fro motion. So this is about the pendulum, and this is the structure of simple pendulum. And now we are going to discuss about this. Here you can see a simple pendulum. Actually, generally we are using a metal bob here. Now I have no metal bob, and that's why I'm just using such a ball here. So I'm just adjusting the length. First I will show you. I'm just selecting this much length and I'm just oscillating this. And you can see here it is moving from this to this. And now I am increasing the length and I am oscillating this. Now you can see that it is moving from here to here. Again I am increasing the length and then moving this. Have any difference you can see here? That is, at the initial stage the motion is very fast. And when I am increasing the length, you can see that the motion is getting little slower. Actually, the difference happens between the time actually. That means, I just focus here. The length of the pendulum depends upon the oscillation. Now just understand that the length of, I'm just taking it as L. So the length of the pendulum depends upon the motion of this pendulum. And also, here we have a bob. Also the mass of the pendulum depends upon the motion. So actually here two factors influencing the motion. One is the length of this thread and the mass of this bob. And we are not considering the mass of this thread. We are just negligibly taking this mass of the thread. Now, we are talking something. When this bob is moving, it is getting a maximum height. And then it is moving to the forward. Again come to backward. That means this bob is getting a maximum length here. And I am calling this point a name called extreme position. Extreme position. That means when this bob is at rest, we call that position as mean position. Mean position. Mean position. That means when there is no oscillation and when this bob is at rest, we call that position as mean position. And when I am just giving a force on this, then it starts to oscillate. And at a particular point, it will attain the maximum height, and that height is called extreme position. And the bob is unable to go further length than this extreme position. So that is the extreme position, and this side also you can see such a point, and that is also called extreme position. Extreme position. So there are having two extreme positions and one mean position. You want to remember, mean position is what the bob is getting at rest, and the extreme position is the maximum height that is getting by this bob. Now, we want to study, I just said that I am just oscillating this pendulum. So, the oscillation is done for this. Oscillation. Now, we want to study what is one complete oscillation or one oscillation of pendulum. That is, how we can measure one complete oscillation of pendulum. That is, I am starting my oscillation from this 1. Here it reached. At this point 2 it reached. Again here and reach this point. Then I can say this bob completes one oscillation. That means I can show you here. The oscillation starts from here, going through here and again back to this position. Then only I can say that this pendulum completes one full oscillation. Or when this pendulum just move from here, moving and stop here, what we can say? This only completed half oscillation. When we want to measure one full oscillation, it needs to move from here, moving through this point and come back. Then we can say this pendulum completed one oscillation. And also we can measure this oscillation from the mean position also. At the first step, I just show you how we can measure the oscillation using or starting the oscillation from the extreme position. Next, I am showing you how we can measure the oscillation from the mean position. That means this is moving to first extreme position and coming to here. Then this pendulum only completed half oscillation. Then this pendulum moving to this side and again come to this point. Now this is one full complete oscillation. That means I am showing you once again, moving to here, come back, moving to here, come back. That means 1, 2. 2 times this bob is coming here, then what? It completes one oscillation. No need of getting confused with this. Just understand that it needs to 1, 2. That is what? One complete oscillation. Then next we want to study about time period. Time period. What is this time period? This is something related to this pendulum and the bow bundle. What is this time period? Time period is very simple. That is the time taken by the pendulum to complete one oscillation. That's why I just introduced what is this one oscillation. So, time period is the time. Time period is the time taken by the pendulum to complete one oscillation. That means here, when the pendulum is starting the oscillation from here, it is going to this point and come back. Then we can say this one oscillation. And this time period is the time. It may be 1 second or 2 seconds like that. The time will depend upon the length of the pendulum. That means here when we select small length, then the time period will be less. And when I am selecting very length, then it is having much more time to complete one oscillation. So you just want to remember what is time period. Time period is the time taken by the pendulum to complete one oscillation. So this is all about this time period and the pendulum. In your textbook there is having one experiment to find the time period of pendulum. Now we are going to do this experiment. We want one simple pendulum, one stopwatch. Now I have no stopwatch and so I am doing this experiment using my watch. For that I need one table. The table is this. SL number, time for 10 oscillation. We are taking the time of the bob for 10 oscillation and also time period. So this is our table. The experiment is very simple. I will repeat the experiment 3 times. Generally, all the experiments in physics we are repeating continuously for 3-5 times for reducing the error that we are doing. So that's why we are repeating the same experiment 3 or 5 times. Now I am just doing it for 3 times. And you just observe how I am measuring the time of oscillations for 10. So I am just selecting a particular length. Here no need of taking length is there. I am just taking a particular length and I am looking for the time and start the oscillation, 10 oscillations. 1, 2, So here it take 15 seconds to complete 10 oscillations. Now I am taking the same length and measuring again this time. We are just leaving some oscillation at first. Again, it is around 14 seconds. I am repeating the experiment using the same length and I am looking on the watch. I am oscillating this. So, it is almost 16 seconds. Actually, we are conducting this experiment using a particular stand and all. So, within the experiment, I have so many limitations with I have no stoppers and also having certain sort of some mistakes are there. So, I just took a fast manner, just took the time as 16 second, 14 second and 16 second for the time for 10 oscillations of that bow. So, now we want to find the time period. How we find the time period? Time period is the time taken by the pendulum to complete one oscillation. We took here 10 oscillations. Then how we find one oscillation's time? Very simple. You just want to divide this 15 second by 10. So we get it as 1.5 second. This is 1.4 second. And this is 1.6 second. So you can see here 1.5 second is the 1.4 second is the 1.6 second is the. Generally in such values there is having small variations with the values and we take the average value of this. That means we just add these three values and divide them by 3 and we get finally the value as 1.5 second. So I am concluding as for that bow with the particular length, the time period for one oscillation is 1.5 second. You just observe the experiment and remember how we are doing the experiment. Just only that. No need of getting confused with this. And you want to remember what is the time period. Time period is the time required for the bow or the pendulum to complete one full oscillation. And in this area you want to remember what is one oscillation. I am repeating. When the bow is moving from the extreme position and when it come back to the extreme position, then we can call it as one full oscillation or simply we can say it as one oscillation. The next topic is unit of time and speed. We discussed about time and in the last class we discussed about speed. Now we want to study the unit and in the next class we will discuss how to write the unit for the time and the speed. And also we want to study how to measure speed. Today we studied how to measure the time period of pendulum. So it's enough for today. You want to read your textbook and write the notes and also you want to study this all. Today it's enough and we will meet in our next class.